So let me start the session. Good evening, one and all. Join this meet. So this is Saravanan, Prime Minister Research Fellow and PhD Scholar of Department of Civil Engineering and NIT Tiruchirappalli. So a small brief introduction about me. Those who joined today are new. So I am a PhD scholar in NIT Trichy and a PMRF scholar. So as a part of PMRF deliverable, I have to take 2 hours of course in outside colleges or in NPTEL. So as a part of PMRF deliverable, I am taking this NPTEL course air pollution and control. So already I have taken two other courses like integrated solid waste management and plastic waste management. You can see that lecture videos in YouTube, and this will be the eighth week problem solving session for the course air pollution and control. So first 7 weeks we have discussed about the basics of air pollution, air pollutants and their impact on the human health, ecosystem and different materials and economics laws and all. And then we also discussed about the dispersion of the pollutant and dispersion modelings, and we have discussed about data acquisition and modeling of air pollutants in this last 7 weeks. And this week's I was actually stuck with this IIT Hyderabad PMRF symposium, so I couldn't take on Tuesday because of my flight. So this today I have postponed the session for week 8, and next week Tuesday 6 to 8 we'll have week 9 session. So this 2 hour session we have planned, like first 1 hour will be the same lecture material what sir has taught in the NPTEL portal, and the other 1 hour will be the old assignment solving session. We can also ask clear all the doubts. Okay, so I'll start the lecture now. Yeah. So now we have came last week we have discussed about the indoor air quality. So indoor air quality, we have also some case studies that and all we have discussed how they have monitored the indoor air quality and what are the, because the myth is we know only the air pollution is existing in the outdoors, but what we have what the data says and what the statistics says, the indoor air quality is 4 times worse than the outdoor air quality. So it should be taken with the proper care. Okay, so and another one important thing is people are inside outdoors, I mean indoors for 90% of their time, and only 10 times of the 10% of their time outside. So it should be taken care because 90% of their time will be spent in indoors. We have lots of air pollutants like mist, pollens, even beds, from curtains to furniture to everywhere we could see pollutants. Even a small dust will also a pollutant, and also we have microbial indoor air pollutant, that is under biological contaminants we have discussed, right? Some pollen, some mist, some bacteria, even coronavirus is also a air pollutant. It has traveled through air, right? Airborne disease. So like that, these are all need to be controlled. That and all we have discussed, and lots of controlling measures also for each pollutant we have discussed. So this week first section will be on a case study related to indoor air quality. So in UAE, United Arab Emirates, they have done a indoor air quality case study for the nursery buildings. They want to know how the child are going to get affected by this indoor air quality. Okay, so why they have chosen children and infants? Because human, as a normal adult human, we will respirate or we will inhale 150 milliliter of air per minute, but compared to the child and infants, they will inhale 400 milliliter per minute per kg of their body weight. So think about that. Like if they are if I am a 60 kilo adult male, then I will 60 times 60 into 150 ml, that much liter of air I will inhale in a minute. But if you see children, they will inhale a lot, so they are more prone to this air pollutants, and their impact and the effect of this air pollutant will be more in the infants and the children. So it is very important to maintain pleasant air for this type of nursery schools and all, because that there only they will stay for a long time, right? So that need to be taken care, because they are also inhaling a lot, and exceeding the indoor air quality standards can not only lead to decreased learning efficiency but also serious sick building syndrome. That was we have discussed in last week, right? Sick building syndrome is the one which will be not adaptable for the people to be inside. Whenever you are entering into a building, you are getting sneeze or cough, then the building is having some um, pollution prone parts, that's like air pollutant. That's what called sick building syndrome. So that also need to be taken care in schools or nurseries for the people, that will affect their learning ability. So how to reduce the adverse effect on this health of the impact infants and the children? So there are three methods. One is controlling the source of the pollutant, paint-free walls. Furniture should be properly sealed from emission of air pollutant, and proper cleaning. That are controlling from the source. Second one is improving ventilation, because ventilation will also get rid of all the indoor air pollutant. Another one problem with the ventilation is that pollution from the outside may also enter inside. That is another one problem that also need to be taken care based on the outdoor air quality. Third one is removing pollutant via purification. So if it is a system with more industry prone furniture, emission prone furnitures are there, that need to be properly removed via air pollution control measures like purification systems. So IAQ is the indoor air quality. Indoor air quality was measured in this study. They have taken 16 facilities, and they effectively they given three methods to effectively reduce the indoor air pollutant. So what are the general method they have used? Improvement of ventilation, control by purification, also control from the source. These are the three methods they have followed. So examples of source control techniques like what we can use of low emission building furniture. That's what I have told, like paint free walls and all. Ventilation we can improve by two methods. That also we have discussed earlier. Ventilation can be done with natural ventilation by proper windows and the doors. Second one is by mechanical ventilation. So that will also increase the indoor air, indoor inflow of outdoor air. Then removal of pollutant could also be air purification through absorbing and filtering pollutants and decomposition them by catalyst. So absorption or adsorption principle also we can use to remove the air pollutant. So that's called building bake out. So that's the process of using indoor heating to remove volatile compound present in the buildings, because volatile matters will means what is volatile, that will become solid to vapor at high temperature. So we are heating the building to remove the volatile organic compounds. So that is one type of method, that's called building bake out. It's a kind of baking system. Building we are baking. You got it. Then most of the studies mainly focus on the residential building, but there are few studies on the nursery IAQ. That's what they have taken this as a consideration. So and the improvement they can do by installing air purifiers, changing building finishing materials, and installing ventilation facilities. So 16 nurseries were taken for the study in Dubai, Sharjah, and Ajman. And what are the pollutant they have measured? Temperature, humidity, these are all parameters. And then CO2, TSP, that is total suspended particulates. Then CH2O, formaldehyde. Then volatile organic matter, that is VOC, were measured in total 35 classrooms. You can see like 16 nurseries and 35 classrooms. What is the impact? Room to room impact also they have measured. So this also you can take as a project if you are in undergraduate or all. So in your institute, how the indoor air quality is varying in each department, each labs and each classrooms, how it is varying. That also you can take as a UG project or PG project. This will be having a good impact. Okay. So this case study was done in UAE. So I'm just giving a glance for the new joinees. Like this case study was done in UAE for the indoor air quality measurement in a nursery building. So 60 nursery they have taken for 35 classrooms, and the degree of contaminants was compared with the WHO IAQ standards. And these are the parameter they have measured: temperature, humidity, CO2, total suspended particulate matters, formaldehyde, and volatile organic compounds. So based on this measurement results, they have proposed some improvement techniques. How they measured these parameters? So what are the measurement equipment? Temperature and humidity with sensors, data loggers, and carbon dioxide with TSI 7475, and formaldehyde is by formaldehyde meter, TOVC with environment VOC environment meter, and particulate matter with the potable air samplers. And measurement time also you can see, as per the we have also a Indian standard code for measurement of air quality standards are there. You can see the result. So it's based on outdoor room 1 and room 2 data they have compared here. So compared to the outdoor is a blue one, which is less than the limit given in the WHO standards. 920 is the limit for carbon dioxide, but all the outdoor air quality is lesser than that the limit. So it is good. Outside is good, but inside if you see pink and yellow dotted lines, so that is most of the time that is above the standard limits. So you can think why the carbon dioxide is more inside the nursery rooms and on this outside compared to the outdoor air quality. So as I mentioned, carbon dioxide standard prescribed in WHO was 920. So the source of carbon dioxide is breathing of the children, because we will consume a lot of oxygen and we will emit the CO2. Because of there is no ventilation, the CO2 is rolling inside the building. That will increase the concentration of CO2 inside the building. But outside, if you see, people are also inhaling, but it is dilution of the carbon dioxide level. That's why it's getting reduced. Both the classroom approached exceeding 2000 ppm, twice the severity maintenance standards. So 920 is the limit. 2000 is double the standards. So you can think how much they are prone to CO2 as a pollutant. Then total suspended particulates, the limit is 100 microgram per meter cube. And most of the standards, if you see, I mean, sorry, the levels of TSP will be comparable with all the three rooms. So where the TSPs are coming from, it's due to the influence of dust from the surrounding construction sites and factory, and also a lot of vehicle flow also that's happening. So the TSP can be entered from outdoor to indoor. That is the only source of TSP. Then volatile organic carbon. Volatile organic compounds, if you see, the limit is 400 microgram per meter cube. The unit is microgram per meter cube. That much lower amount it should be, because volatile organic compound, the impact and all we have already seen, right? If you see the outdoor, everywhere the outdoor is very less. Only the indoor quality is very high. So you can see indicating a higher level of pollution, exceeding the recommended standard levels, and also the formaldehyde. If you see, the blue line will be less than that. The limit is 100 microgram per meter cube. That is very serious degree of contamination compared to other nurseries. Which one that they have given code for different nurseries. That is 16 nursery buildings. And formaldehyde concentration is higher than the outdoor air. That is another impact. All the pollutant parameters are higher than the outdoor air. So it is judged that there are contaminated by various finishing materials and formaldehyde emitted from teaching materials, like you can say chalk paste or any pen, whatever the whiteboard markers we are using, that may emit volatile organic carbon as well as formaldehyde. And carbon dioxide will have an impact if you see time-wise variation. Earlier it was like different nurseries, 60 nursery buildings. Now it is comparable with the time, morning, afternoon, and evening. If you see, the carbon dioxide level is lower inside the building when morning. Once the children come and occupy the building, it got increased due to respiration. And afternoon, it is becoming less due to some playing activities and all. So again, the TSP, if you see, afternoon only it's higher compared to the morning. Formaldehyde is higher due in the morning, because once the building was locked, there is a emission of formaldehyde from the furnitures as well as from the boards. So that was occupied inside the building. So that will, so the formaldehyde that's emitted from the furnitures that got accumulated within the building. So that when you got open the building up in the morning, the pollutant got diluted. So you can see the reduced level of pollutant from the afternoon and the evenings. Got it? That's the ventilation problem. And same compared to the TOC also, it's higher in the morning only. So what we can do to improve the indoor air quality, they have suggested to install the air purifier to remove the air pollutants. Then change of building materials. As I mentioned, some of the furnitures and the teaching material need to be changed. The replacement with the finishing materials. And installation of new ventilation system to dilute the polluted air. You got it. So there are three groups. Installation of air purifier is AP group, building material change is BRIM group, and new installation, ventilator installation is NV group. So all the things they have installed in number of nursery buildings. What is that did for installation of new air purifiers, kind of AEHPA, that is a high efficiency particulate matter filter. So you can see 99% removal is there in this if you install this type of high efficiency purifiers. And change of finishing materials such as wood they have used, and wallpaper were replaced with the four sides of the nursery room walls, because the paint may also emit some volatile organic compounds. That's TOVC. And new ventilation system like natural and also mechanical ventilation were also installed, because that performed very well. So how they have compared the change after installing this type of improvement techniques? So they have suggested degree of improvement by subtracting the earlier concentration with the new concentration by the base concentration. That's the earlier concentration is 100. You will get the reduction rate or the degree of improvement. So that they also assessed after installing all the methods. So they have understood that 46% improvement was there in TVOC, and particulate matter, suspension particulate matter will be reduced by 21%. Carbon dioxide reduction was happened 18%, and formaldehyde with 13% with the air purifiers, I'm saying. Then this will be the earlier concentration. This is the reduced concentration. You can see at the top and bottom of this horizontal line. And the building material change, if you have seen, so formaldehyde is having more impact, like minus 500 times reduction in the formaldehyde concentration if you change the building material, as I mentioned. So because the furniture emits most of the formaldehyde within the building in the during night times, so that all got reduced because of this posting of wallpapers in and around the walls, and TOC concentration was also reduced by 800 percentage. You can see the huge impact by changing simply the building materials. And the third point is the installation of ventilation has also have a huge impact, like 78% reduction in the formaldehyde, and 17% is the lowest reduction level. And TVOC also decreased by 52%. That's the second most with the average decrease rate. So again, new ventilation system also reduced the carbon dioxide levels. So as a conclusion, I can say that the air purifier has the highest efficiency of 96%, and TU was decreased and TSP also got decreased. Most effective way to remove the concentration of pollution, indoor air pollution I'm talking about, that will be by installation of ventilation system. That will also be mechanical ventilation system. Some places you can modify the building materials also. So this is a case study and their recommendation to the building. So this also you can take as a project and you can work on. So third one is the third one is the impact of air pollutants, that is the indoor air pollutant on ozone layer depletions. So we have two concepts. One is first we have seen about the impact on the ecosystem, environment and materials and human health and animals health. Here we are talking about the global and regional environmental. So it's not about indoor. I'm talking about the whole air pollution. So global and regional environmental issues. First one is ozone layer depletion. Second one is global warming. Third one is acid rain. These three we are going to see in the upcoming lectures. Okay, the major impact of air pollution is ozone layer depletion. How the ozone layer is getting depleted? We know ozone layer is in the stratosphere. We know ozone layer is getting depleted because of loss of chlorofluorocarbon. But what is the science behind that? Why it is related to air pollution? That and all we are going to see. Okay. Yeah. So you know like ozone is a highly reactive gas because many water treatment we are using ozone. Like advanced oxidation treatment, if you see oxidant, we are using ozone because ozone is not stable because O2 is stable, oxygen is stable. But whenever we are having third molecule of oxygen, then O3 will not be stable. It will always be reactive and it will lose electrons. So that can be used for treatment. So it's a reactive gas. It's a good gas. Ozone is a good treatment, having a good oxidizing ability. So most of atmospheric ozone is concentrated in a layer of stratosphere. You can see like ozone, if you measure from troposphere to mesosphere, you can find stratosphere it's having high concentration of 15 to 30 kilometer. You can see that is a thickness 15 to 30 kilometer above the earth surface, above the earth surface. Ozone molecules are constantly formed and destroyed in the troposphere. It's not always be formed, it will also destroyed. So forming, destroying, that's the equilibrium, and it is maintaining the same thickness of ozone layer. The total amount has remained stable during the decades, but now it got started reducing. Why? That's what he due to anthropogenic human activities. The ozone layer, what is the purpose of ozone layer? God has created this as a proper system to how the design of earth with the proper gas at the stratosphere to filter the harmful UV radiation from the sun not to reach the earth surface. That and all a good engineering mechanism you can think about. So a ozone layer absorbs the amount of harmful UV radiation. There are three types of UV, you know, based on the wavelength. There is a UVA, UVB and UVC, but the harmful UV is the UVC, that is having a smaller wavelength. That alone can be filtered from the ozone layer. You got it. So UVA can reach the Earth's surface, UVB will be partially filtered, and UVC will be fully filtered out by the ozone layers. UV radiation has been linked to many harmful effects. Like if it reaches the Earth's surface, it will create skin cancer, cataracts to people, that is blurred vision, and harmful to vegetation and crops, and also to the marine life. So this and all can be protected by the stratospheric ozone layer. Got it? How it is protecting? Whenever the how it is forming that ozone, I am saying, in the stratosphere it is formed by oxygen will be there in the atmosphere. Whenever it's reacting with the sun's ultraviolet radiation, it will be split into O and O. One part of O will be joining with one oxygen atom, and another one will be with another oxygen molecule. It will combine and form the ozone. So it's a whole new reaction will be 3 O2 with sunlight gives you 2 ozone molecule. 3 oxygen molecule with the sunlight gives you 3 ozone molecule. So the H nu is the photon with the energy dependent, that is the sunlight, UV sunlight. That when it reacts with the oxygen, it will get the ozone. Okay, the UV radiation with the oxygen and the ozone prevents the penetration of the shortest UV. That is, the UVC will be purely trapped from penetrating. Then tropospheric ozone formation. That is the problem. There are two ozone. Stratospheric ozone is good. Whenever the ozone is there in the stratosphere, it is good to the human health and to the earth. But whenever there is ozone in the troposphere, then there comes the problem. Why? This is formed by different air pollutant. Whenever it's combined with the sunlight, the ozone will get formed. But it is again having a human health effect. Like ozone, when we inhale, there is a very minute limit prescribed in the standards for ozone. So ozone should not be there in troposphere. So that is the limit for tropospheric ozone formation. So how it is forming by photochemical reaction of the precursors. Precursors are the combining molecule that will form the ozone. Okay, so what are the precursors? Nitrous oxide, volatile organic matter, both are emitted from the automobiles. So that's why ozone is more during morning times, because we are starting at the 8 to 9, we are using lots of car and vehicles to travel to the office and to the schools, and evening if you see 4 to 6, again we are having lots of emission from the vehicles. So morning if you see, lots of NOx is formed. Where NOx is coming from? Emission of fuels from the automobiles. And where volatile organic carbons are coming from? One is from the automobiles, one is from the volatile organic. You see, this is the part from the power plant. Two are major air pollutant that will be the precursor for the ozone formation whenever reacting with the sunlight by the process called photochemical reaction. We see morning 6 a.m. you will get emission from the NO, CO, and from the automobiles. Whenever it's reacting with the photons from the sunlight, then it will form NO2, CO, and HC in the noon. And early afternoon you can see ozone, carbon monoxide, and TAN, that is peroxyacetyl nitrate. That is a photochemical smog and haze. This and all reduces your visibility, and you can see a dark mist around you. In Delhi and all, if you see, that's the air pollution problem. That's why they have reduced the use of vehicles. That will be the major source for air pollutant. And after wind, this can be carried to ozone. So highest ozone concentration you can see in the afternoon. Peak concentration of ozone will be occurring during afternoons. So, what's the problem with the tropospheric ozone we had seen? So that's a cancer-causing agent. Stratospheric ozone is good. That will prevent us from cancer. So there are two types. Whenever ozone is there in the troposphere, it's a problem. Whenever ozone is there in the stratosphere, it's good. Okay, what's the problem now? The stratospheric ozone is getting depleted. How? Because of the chlorine emission. So chlorine and bromine are the halogens, you know. There is a halogen compound in the periodic table: bromine, chlorine, fluorine, iodine. These are all halogens having one negative ion. So these halogens, when we are emitting into the atmosphere, come in contact with the ozone in the stratosphere. So we are emitting at the troposphere only, but it will reach the stratosphere by proper dispersion and destroys the ozone molecule. Because chlorine, when reacts with the oxygen, it will have a destruction mechanism. So ozone will be disturbed into O and O2. So one chlorine atom can destroy around 1 lakh ozone molecules. Think about a huge impact of one chlorine atom. So it has a longer lifetime, and it will stay in the stratosphere, and it will destroy 1 lakh oxygen molecule. So see, oxygen when combined with O, we will get ozone. But the same chlorine catalytic cycle, it will again get destroyed into O and O2. Why I am saying chlorine as a catalyst? Because it's not taking part in the reaction. It's just destroying the ozone into O2 and O. But it is not taking part, or it is not combining with any O. So the problem is we are having chlorine O also, but it will be getting. You can see there is a video here, but it's not playing. This animation video. So again, this O will be taken out. So the chlorine is acting as a catalyst, and it will stay, and it will destroy another 1 lakh molecule. Then only it will destroyed. So CFC, where the chlorine is coming from? Now the problem is the chlorine and bromine. Where the chlorine is coming out? That's due to anthropogenic activity, human activities. Chlorofluorocarbons. They are chemically very stable compounds. Remains in the stratosphere for long period of time. So it will reach the stratosphere, which imbalance the ozone formation. Where the CFC is coming from? Like we are using lots of refrigerants, our fridge, our perfumes, everything have CFCs. Now all the nations are working with how to reduce the CFCs, chlorofluorocarbons. So that's the problem here. So that undergo photo dissociation. This is called a photo dissociation process, producing chlorine atom, which would interface with the ozone. So CFCs will form the chlorine. Chlorine will go to the stratosphere. It will attack the ozone, and the ozone will be destroyed into O2 and O. So this is a whole process of destruction of ozone layer in the atmosphere. I mean stratosphere. You got it. Chlorine plus ozone will give you this O will be attracted here. Then ClO plus O2 will be there, and then ozone will be again. This O will be taken out. Chlorine will be going with another ozone. Chlorine atom will provide a destruction pathway, shift the steady state of the ozone. And one chlorine atom destroys many ozone molecule. What is the impact? Whenever the ozone getting reduced, it's not that ozone hole also we are going to discuss anyway. So it has a lots of impact whenever this ozone layer getting depleted, its function will get affected. What is its function? It will filter the UV rays, right? So that will get affected. Now UV rays will start entering into the atmosphere and its surface, affect the human health, material, plant, marine ecosystem, and material. Even you can see here, human health, you will see cataract, melanoma, skin scan, because UV are light, right? That will affect your skin, it will affect your eyes, and materials you can see like biopolymers, polymer will get restricted because UV light having lesser wavelength or UVC that has a high energy, so that will easily destruct the biopolymers and affects the UV radiation, adversely affected by the UV radiation. High UV radiation level will accelerate the breakdown of this material, so they reduce the lifespan. Whenever we have a product, that will lifespan will get reduced. And then plant, you can see destruction of the plant, physical developmental process will get affected, and damaging effect of the UV. Some UV, if it is falls on the leaf, that will have a color change effects. Then chlorophyll intake will be lower. Then marine ecosystem, that will also, because most of our phytoplankton will be at the top of the oceans in the euphotic zone only. So light can easily enter into the top layer, and it will affect the survival of this type of phytoplanktons, and it will damage to earlier stages of fishes, crabs, amphibians, decreases the marine life ecosystem, everything. Oh, this is because of the ozone hole formation. What is ozone hole? That is not a actual hole. That is decrease in the thickness at a point of whole ozone layer. As I said, ozone layer is everywhere around the Earth's surface. At a point or at a area like this much kilometer square, we can see a reduced thickness of ozone layer. That is called the ozone hole. That is huge. In a big ozone hole is there in above the Antarctic zone. So that's what called the Antarctic Spring, South Pole. There you can see in early 1980s they have discovered the ozone hole. That is the reduced thickness of ozone in the that is 3 mm or 2 mm only. That much if you reach, it's called ozone hole. So that is not really a hole, that ozone layer, but there is a larger area of stratosphere with extremely low amount of ozone. The concentration got reduced. So you can see the 1987 data at latitude. You can see this area having higher ClO and lower ozone. So chlorine monoxide got reduced, and ozone level is getting ozone level is getting reduced, and the chlorine monoxide level is getting increased. If you see globally, you can think like not only Antarctic zone, that is not only the South Pole zone. You can also get this type of ozone hole in North America, Europe, Asia, everywhere you can find. Even in India, tropic regions also, you can feel some areas having huge sun impacts that and all due to this type of ozone holes only. So everywhere it's spread, but Antarctic zone is having a huge loss of ozone. The chlorine and bromine are the major culprits here. So that exposure to the UV light in the stratosphere and ozone, that's called ozone depleting substances. Chlorine and bromine or CFCs are all ozone depleting substances. How to measure these ozone depleting substances? By a measurement called global warming potential. Why it's called global warming potential? Whenever the rays enter into the earth, it will be reflected by the earth surface, but it will be trapped inside the earth surface. So if it is reflected back, there is no problem. If it is trapped inside, then it will have a huge heat accumulation capacity. So the globe is getting warmed. That's why it's called a global warming. So if you compare, CO2 is having one global warming potential. CO2 as a reference, you can measure the global warming potential for any ozone layer depleting substances. So ozone depleting substances are ODS. The first one is a chlorofluorocarbon. If you can see, the GFW global warming potential is around 5,000, 10,000. Halogens are 1,000. Chlorine tetral 1,300. Like methane is having 20 times. Methyl bromide is having 5 times. Nitrous oxide, you can see this type of multiplication with the carbon dioxide's potential as a reference. We can think about the global warming potential. So the ozone depleting substances like releases chlorine, include chlorofluorocarbons, hydrochlorofluorocarbons. Now they are transferring. Initially it was chlorofluorocarbon, then they have transferred with the you can see carbon. I'll write and tell you. So carbon, four valencies are there. If it is 4 with H, that is called CH4, methane. Right? So if it is 1 is chlorine, sorry, 2 are chlorine and 2 are fluorine, then it is called dichlorocarbon. Then they will replace 1 with hydrogen to reduce the impact. That's called chlorofluorocarbon. Then they have also taken out the chlorine, so that's called fluorocarbon, difluoro, monochlorocarbon. This type of different combinations they have tried to reduce the ozone depletion impacts and all. Later they have found only the fluorine will be better. Later they have identified H will be better. So they have replaced everything with H. Now monochloro carbon is identified as point. But later lots of refrigerant and their advancement has happened, and now they have purely transferred with the organic refrigerants. So that you can find in I will also google it and tell you the numbers. That is all refrigerants numbers that can have a less of ozone depleting potentials. Okay, and you can see here, so the fridge, the air conditioners, the CFCs, everything have uh, everything release this halogens like chlorine and bromine, having huge global warming potential. So volcanic eruption is another global ozone depleting substance, because volcanic eruption releases lots of, it's having indirect effect by releasing lots of particulate matter and aerosols. But the effect is short-lived, not like a refrigerant. Whenever there is an emission, 1 or 2 weeks or 1 or 2 months, there will be the impact. So, 1928, they have scientists have discovered it's due to chlorofluorocarbons. And 1973, they detect chlorofluorocarbons in the atmosphere. And 1974, they got the Nobel Prize for discovering chlorofluorocarbon and N2O can break the stratospheric ozone. Then only they identified, okay, it's having the impact and it is depleting the ozone layer and we are getting affected by the UV lights. And 1975, bromine was also included. Not only chlorine, bromine was also used in the fire retarding halogens that has a potent for global depleting substances. And in 1985, the team discovered ozone hole. So above the Antarctica, 7.5 million square miles. So you can think about how huge it is. More than Antarctica's area. That double the Antarctica's area. That much area, the ozone is getting depleted. And adverse human environmental and human health effects. Now, 1991, international scientists agrees CFCs are depleting the then only they have identified after lots of scientific research and data, they have agreed that CFCs are depleting the stratospheric ozone. So 2000, Japan Meteorological Agency, they report the ozone hole and above the Antarctica by imageries. and 2015 ozone hole is reported as the biggest ever, exceeding that of 2006. That's why Vienna Convention, that is Montreal Protocol, happened. So Montreal Protocol, you can think lots of conventions and this type of parties have come into discuss about this ozone layer depleting substances. First of its kind is 1985, the Vienna Convention for the Production of the Ozone Layer, signing the Montreal Protocol on the substance that deplete the ozone layer in 1987. And Montreal Protocol, that's a place. Vienna is a place. Montreal is a place that the protocol happened. So they have signed new data showed worse than expected damage to the ozone layers. In 1992, Montreal Protocol agreement to end the production of halogens. So there should not be any halogens. So no chlorine, no bromine related refrigerant. So 1994, CFCs by 1986 in the developing countries, they have signed the agreement. And measures taken under the Montreal Protocol, it's expected to fully healed near the mid of 21st century. So we are near the mid of 21st century. We have to fully heal the ozone layer. If we not emit any halogens, there won't be any impact to the ozone layer, right? So that's the aim. So 1975, S. Johnson announces cooperate phase out of CFCs as aerosol product propellant. So first he initiated to stop the CFCs usage, to phase out the CFCs. So all the countries have cooperated because it's a global issue, not only the national issue. So all the countries have come up and discuss about this, and they have come up with a agreement to phase out the CFCs. So they didn't produce, and whatever they have produced, they are phasing out. And in 76, UNEP calls for an international conference. And then 1978, US bans the non-essential use of CFCs like propellant. 1981, Global Convention to Protect the Ozone Layer. 87 is the 24 countries signed for the Montreal Protocol. That is the 1987 protocol. The 25 countries, they have uh, signed to reduce the substances that deplete the ozone layer. And 1989, Montreal Protocol banned the production and consumption of CFCs at 1986 levels. 1990, Clean Air Act. 1992, CFCs phase out. They have a accelerated CFC phase out date on 1995. There's the deadline they have taken off. 1993, there's a halts in the production of CFCs. Again, 1994, it eliminates on the production and import of halogens. US have first started and eliminated. 1998, 96, US eliminates on the production and import of CFCs, along with other carbotetrachloride, trichloroethane, hydrobromofluorans. And then 2002, all developing countries have signed to that parties to the Montreal Protocol banned methyl bromide production in the 1995 to 1998 average level. 2004, they accepted to reduce the consumption of HCFCs by 35%. And then 2010, they reduced the consumption by 65%. And 2015, 90% that has already achieved. And 2030 and 40 are the target goals to reduce complete phase out. Already we have reduced 90%, so complete phase out. 2040 will be complete phase out of HCFCs. So that's the scheduled Montreal Protocol's aim. So they are planning. All the nations are working to achieve this goal. So if we reduce the emission of chlorine and bromine halogens, and also we have phased out this type of halogens HCFCs, then we could see the healing of ozone. That's what the aim of Montreal Protocol. So the conclusion is ozone layer protects the Earth's surface, and the major air pollutant like CFCs and are the emitting chlorines and bromine kind of halogens that will deplete the ozone layer. That's called the ozone layer ozone depleting substances. There is a convention that happened in Vienna and the Montreal Protocol. They have proposed strategies to reduce this type of phase out this HCFCs. Finally, they are working on with healing the ozone layer. The second issue is the global issue is the global warming. So as I mentioned, global warming is due to the increase in the surface temperature of the earth. Not only surface temperature, the atmospheric temperature of the earth. Why it's happening? Whenever the ozone layer is getting depleted, UV rays can enter directly, and also the air pollutants like methane, carbon dioxide, they are having global warming potential that could trap the heat within the earth's surface, that will not allow it to emit out. So global warming is a long-term heating of Earth's climate system observed since the pre-industrial era. higher period. If you see like 1950s and 1990s, there is no term called global warming. But after the industrial era happened, you can see 2016, 20, how much steep line in the increase of temperature I'm talking about, and increasing the global surface temperature 1 degree to 1 degree rise. Now we are facing of 1.5 degree rise in the temperature. So human activity, primarily fossil fuels burning, increasing heat trapping greenhouse gases levels in the Earth's atmosphere. So you can see here what are the global warming indicators. There are various indicators like global warming potential, radioactive forcing, annual greenhouse gas index. So GWP, RF, and AGGI. These are the three indicators for the global warming. Global warming. So we are going to discuss all the three. So we are based on this, we are promoting some emission reduction strategies. So greenhouse gases, as we know, they are, what is greenhouse gases? They are the gases have the potential to block the long wave radiations like UV. So that is again related with ozone layer depletion only, because ozone layer depletion will allow the UV, that is a long wave radiation, that was trapped by this kind of gases, that is greenhouse gases, increase in the Earth's surface temperature. That is the impact. So already, but greenhouse gases are good. It has maintained the proper heat in the Earth. Otherwise, we will also be like Mars. So Mars is already a frozen and unlivable planet. Like so, but Earth is having a proper climate, a proper weather, and a proper temperature. A good heating system is there due to the presence of this type of greenhouse gases. But naturally present greenhouse gases are fine. Whenever we are increasing the concentration of greenhouse gases by human activities, there comes the problem. So there comes the higher heating of Earth's surface. So that's the problem now. So artificial increasing the natural greenhouse gas, that will be the naturally there is a greenhouse gas effect. Plants are growing because of that. There is a proper control mechanism come forth because of that. But whenever increase, there comes the problem. So gases that trap heat in the atmosphere and are called greenhouse gases, like water vapor is another major air pollutant because it has a greenhouse gas. Nitrous oxide. We are only talking about carbon dioxide, but lot of even water vapor is also a problematic thing. And then methane, ozone, everything has a potential to trap the heat. You can see here CO2, CH4. Why we are talking about CO2? Because it's a huge volume. But even 100 times lesser methane volume is also having the same potential. That's what we are going to discuss in the global warming potential. Carbon dioxide, the primary greenhouse gas, because it's produced in a large quantity, even from volcanic eruption, human activities, deforestation, land use changes, burning of fossil fuels, everything will release this carbon dioxide. But the most important problem is it's a long living and forcing to climate change. And then CO2 growth rate, you can see here after industrial era, I mean 20th century, 21st century, you can see a steep slope of 50% increase from 278 to 417 ppm. That's what 278 is the actual normal carbon dioxide need to be there in the uh, Earth atmosphere. We know, right, 0.0003% is the carbon dioxide level in the atmosphere. Like nitrogen will be 72%, oxygen will be 21%, and trace amount of 1% will be there. Carbon dioxide will be 0.03%, but that is called 300 ppm. If you it increases to 417 ppm, what's the problem? Whenever the carbon dioxide level got increased, it will mix with the ozone water. Then the carbon dioxide is acidic gas. So whenever it's mixing with the ocean water, it will form carbonic acid, H2CO3 or HCO3, that will create acidicity in the water. Coral reef will get eradicated because coral reefs are CaCO3, that is a line as a base will get neutralized by the acid. So coral reef will get eradicated. Lots of fish will die because of a slight 0.1 change in the pH can affect the fish life. So these are all the problem with the carbon dioxide, not only the global warming. Also it will, the increase in the concentration of carbon dioxide is the problem for the coral reefs also. So you can see carbon dioxide from the forest and other land use 11% we are emitting, and fossil fuel and industrial process are emitting 65%. Totally we are emitting 76% of carbon dioxide as a greenhouse gas. Only methane are 16% only, nitrous oxide are 6%, and fluorine gas, that sorry, F gases are 2% only. But why we are talking a lot about carbon dioxide is 76% of the global greenhouse gas. And methane, if you talk about, methane is the second most anthropogenic greenhouse gas. It's emitted from, as we know, like livestock guts, landfills. Landfills are, now only we have submitted a proposal for methane to DST, that's Department of Science and Technology, for methane mitigation strategies from the landfills, because we are working on solid waste management landfills. agriculture and agriculture rice cultivation, as I mentioned, rice cultivation and paddy cultivation has a huge impact on the methane emission and manure management. You can see methane is responsible for 40% of the human has the global warming, not only the CO2. And see it's for growth rate after in 21st century already it's a steep slope. So you can see 2007 onwards it's having a again change in the trend, increase in the trend. 60% from the agriculture activity and 40% from the fossil fuel sources. Totally 16% of the total global warming potential. N2O, that is another greenhouse gas having a potential high potential that's released from organic fertilizers, fossil fuels, nitric acid production, biomass burning. Because still we are working with this type of biomass burning, we will limit the N2O. Then annual increase in the nitrous oxide atmospheric burden, averaging 1 ppm per year over the past decade is also increasing. So they have a parts per billion amount per year they have calculated. That is also a steep slope. Annual increase of 2020 was the largest, if you see. Okay, so this N2O contributes to the 6% of the global warming, total global greenhouse gases. So then another two is F gases, that is fluorinated gases, that is also having a huge potential of global warming. So that is released from synthetic variety of industrial process like aluminum production and magnesium processing. So you can see the fluorinated gases increase. Fluorinated gases again having a problem with the ozone layer depletion. Here also there is having a problem with the global warming potential. That is contributing to 2%. Another one is water vapor and ozone. So ozone is again a greenhouse gas. Tropospheric ozone and ground level ozone is not emitting directly into the atmosphere. It is produced in the atmosphere. It's a secondary pollutant. It is formed from NOx from the vehicles and volatile organic carbon from the industries. Both will get combined and with the sunlight it will produce the ozone. So ground level ozone is a problem. It's a greenhouse gas. Stratospheric ozone is good. It will reflect the ultraviolet rays. Water vapor is another greenhouse gas. Even water vapor is not produced in that much quantity. That is also having a huge potential to trap the longer radiation lights. Like most abundant greenhouse gas, you can say, acts as feedback process. So feedback in the sense increased water vapor content in the atmosphere is referred as feedback process. And water vapor does absorb long wave radiation and radiate it back to the earth surface. That's why it's feedback. That's contributing to the warming. So you can see the global warming potential of water vapor is more compared to cloud, CO2 and others. That's called forcing. So water vapor stays in the atmosphere for much shorter period in days compared to other greenhouse gases because CO2, CH4 has a longer life period, lifetime to stay in the atmosphere. But water vapor feedback can further magnify the warming effect of the other greenhouse gases, allowing more water vapor to enter into the atmosphere as a result of rising carbon dioxide levels. So one carbon dioxide means it will reflect one time, but water vapor will feedback again and again. That will be reacted with the CO2. Then again it will be increasing the global warming potential. That's why the potential, if you see, carbon dioxide is having one. That is a reference for global warming potential. That is a measurement. Then methane will have 25 times of effect. So if you have one carbon dioxide and one methane, methane is the worst. Or if you have 25 carbon dioxide and one methane, again methane is the worst. Same global warming potential. And 300 one nitrous oxide will be equivalent to 300 times of carbon dioxide level, and one fluorinated gas will be equivalent to 1000 to 10,000s of it based on the which fluorinated, chlorofluorinated or bromofluorinated or like that. So 10,000 to 10,000 times equivalent to carbon dioxide. So if we have 1000 carbon dioxide and one fluorine compound will emit a lot of greenhouse gas potential. So you think about that. Greenhouse gas potential of global warming potential of greenhouse gas is the ability to trap an extra amount of heat in the atmosphere over a relative to 1 ton of carbon dioxide emission. It's usually per 100 year. That if one ton of carbon dioxide, if it emits this much amount of heat in 100 years, then the same will be emitted by it means 1 by 25th of the methane. So that's the equivalent relative. So how effective the gas is trapping? That's what we can get from the GWP. That's a potential as a measurement technique. So the CH4 break down quickly and CH4 molecules stay in the atmosphere for over 12 years. So having a standard scale that allows comparison between the emission, reducing the level of different greenhouse gases and emission. This will help you to propose strategies that will reduce the emission. Then GWP 100, that is a 100-year scale I have talking about. 1 ton of CO2 can emit this much of heat in 100 years. The same can be emitted by 1 by 24 of methane. Okay, so that's what the time period given in Kyoto Protocol and the Paris Agreement are based on the GWP's pulse emission over 100 pulse emission is the heat emission. As per the IPCC, change in the GWP values are also made. It's not standard. Like you can see, this is the N2O's greenhouse global warming potential. That's not always equal to 290. That may also vary. And CH4, I have mentioned 24, but it will be 21, 22, 23, 25, 28. So as a year increases, the IPCC guidelines have also revising the global warming potential. We can take a standard of 25. Okay, so it's staying in the atmosphere and different amount of heat. These are all the factors that will help you to identify the global warming potential, how much time it will stay, how, because one carbon may destruct easily, but one methane may stay in the atmosphere for a long time, and it will help again and again trap the heat. So fluorinated gases, you can see 1000 to 10,000. So different fluorinated compound having different lifetime and global warming potentials. And then second parameter is, first parameter is global warming potential. That's what to measure the greenhouse gases. And then second one is the radioactive force caused by various greenhouse gases. That is, the plant absorbs some of this energy and radiates the rest back to the space as heat. So Earth's surface temperature depends on the balance between incoming and the outgoing energy. But this can be, again, one can cool the atmosphere and another can some other compounds will trap the heat, that is heating the atmosphere. So what are the things that will cool the atmosphere, like aerosols, change in cloud due to aerosol, that has a proper effect on cooling of the earth's surface. But whenever it become a black carbon or a soot, like carbon, whenever after heat burning it will become a char, like a black char or black shoot, that will have heating effect. So it's based on particle size, color also. So you can see, whenever the positive and negative forces are balanced out, then the change in the Earth's atmospheric temperature may happen. Some of these changes are natural, but some are anthropogenic activities. Another impactant factor is AGGI, Annual Greenhouse Gas Index. So which is in terms of 1 for 1990, they have taken as a reference, and now you can see in 2019 it was 1.4. So 1.4 times it got increased. So in 2019, AGGI was 1.45, representing 45% increase in the radioactive force, a net global warming influence. So it's getting increasing every year. So we need to produce prepare strategies to reduce the greenhouse gases emission. Also, we have to protect the earth from global warming. So why it need to be protected? Because I am going to tell about the impact of the global warming here. So you can see here, the aerosol pollution and other effects have cooling effect, resulting in net warming of the Earth's surface due to human activities. Then the 2020 was ranked as second hottest year. 2016 was the first hottest, second hottest was 2020, and 2019 you can see the third hottest year. And this year we are facing 2025 summer, not yet started. May is not yet came, but still we are facing a huge temperature rise. Again, in today's news, they have mentioned another 2-degree rise you can feel in this month. So this is the hottest summer of the earth, the history, and the upcoming future years will also have a huge temperature increase that need to be controlled by phasing out this type of global warming potential factors. So what is the impact? Why we need to think about this? Because whenever the increase in the temperature happens, there is an increase in the average temperature, increased weather events like heat waves, forest fires, droughts, heavy rain. One place all the ice will melt and it will increase the water level. One place all become desert. One place flooding, one place drought. This type of weather event you can see, because one part of the world is facing water issue, one part of the world is facing water issue due to flood. So both need to be it's both are problem of water, but one way it is higher, one way it is very low. So this need to be balanced. That are the impact of global warming, increase in the sea level, glaciers are melting. India, you can see, like whole Chennai may go into water, and whole Kerala part and all, these are all coastal regions. You can think about the next one centuries, how the landslide, I mean watershed and landslide landscapes will be due to this effects of sea level rising. 1 centimeter is rising every year, so you can think about how much it will be for 100 years. 100 centimeter is 10, I mean 1 meter. 1 meter of sea level if you rise, you can think about how much coastal regions will go into ocean, and earth's ecosystem, health and society. So what are we can do for mitigation measures? One side we can do mitigation, one side we can do adaptation. So these are the two things we can do. Mitigation is, we know what are the sources like carbon flow, greenhouse gases. How to reduce its emission? We can reduce use of fossil fuels. So we can think about renewable energy, energy efficient. If you don't want, we should not use. So the energy efficient, sustainable transportation, because N2O is releasing, that is creating ozone, ground level ozone. So that need to be reduced. So sustainable transportation like e-vehicles we can transfer. So these are all mitigation measures. But what are already happened, that we need to adapt. Like already there is a flood, there is a lot of rainfall happening in a single day or a single month. Cloud bursts are happening. For that, we need to build resilient buildings to protect us from the flood, and disaster management programs need to be there, and infrastructure need to be. Hello, am I in the line? Hello, am I audible now? Okay, hope I am audible. Sorry for that. My laptop got switched off. I'll continue the session. So there are two methods. One is mitigation, one is adaptation. We know the source, we need to mitigate the sources. Second part is the adaptation. Adaptation need to be done for the already created problems like flooding, droughts and all. We need to have the resilience buildings and resilience infrastructure. We need to cope up with that. So that's the conclusion. Rising by a significant amount in recent decades of greenhouse gases that need to be mitigated, and adaptation need to be taken care. That was, we have lots of conventions, protocol like Summit, Kyoto Protocol, Paris Agreement to reduce the ozone depleting substances, kind of. You got it? So the fourth effect is the climate change. You all know about climate change. It's a long-term shift in the temperature and the weather patterns. This is the climate change. So weather is daily occurring meteorological change. Um, but climate is a shift in the weather for last 30 years average. So if you think about 30 years average, I can say like India having this much temperature, or Trichy is having this much temperature. That got shifted by 1 degree rise, 1.5 degree rise. So ma'am, am I not audible now? Can you able to hear me? Okay, I need to share my screen. Sorry. Hope it is fine now. Yeah, I'll continue. So you all know like the climate change refers to the long-term shift. So weather is a daily pattern, but climate is a average of 30 years weather pattern. So you know, like since 1800, human activity as a main driver for climate change. So it's a blanket, CHGSR acts like a blanket wrapped around the earth and trapping the outgoing long wave heat. So rising global atmospheric temperature. So, you know, climate change has impact like changing the temperature and precipitation pattern, increasing the ozone temperature and sea level, melting of glaciers. What is the problem with the melting of glaciers? Because there may be some carbon embedded into the ice caps. So, whenever there is a melting of ice caps happening, this carbon is getting emitted into the atmosphere. Again, it's increasing the global warming potential. Already, the ice is melting due to global warming. Again, the carbon is getting increased. So, you can think about the exponential increase in the impact and shift in the ecosystem characteristics like length of global growing seasons, timing of the flower blooms, migration of the birds. These are all ecosystem characteristics. Whole characteristics will get changed. So these are the causes of climate change, like natural process such as change in the sun's energy, volcanic eruption also affect the earth completely. But major is the human activity. One is the greenhouse gas emission, another one is reflectivity or absorptivity of the sun's energy. Like whenever there is a normal earth surface, it can reflect easily. But whenever we are having like different structures, buildings that will have different reflectivity and absorbability, that will absorb the heat energy. Like first one is greenhouse gas emission. One is carbon dioxide, which is transferred from the 280 to 414 ppm in 18th century to 2020. Methane, if you see, from 18th century to 2019, 720 ppm to 1800 ppm, it got increased. So think about its potential. Having 25% 25 times higher potential than the carbon dioxide. And nitrous oxide from 270 to 330 ppm, it got increased. So that's the greenhouse effect. So whenever the light is coming, it getting reflected by the Earth's surface. But some of these gases may be present in the atmosphere that get trapped and keep the heat inside the surface. That got increasing the temperature. So another impact is, one is greenhouse gas effect. Second one is reflectivity and absorptivity of the sun's energy. So activities like agriculture, road construction, and deforestation affects the or change the reflectivity of the Earth's surface and leading to the local warming and cooling. So, like some parts may be okay, like agriculture or plantation may cool the surface, but buildings or concretes and bitumens may increase the Earth's reflection pattern, and this effect is absorbed in heat islands. That's called heat island. That's why nowadays people are working with LULC. One reason that areas are warmer in that buildings, pavement and roof tend to reflect less sunlight, so it will absorb a lot. Heat should need to be reflected. It should not get absorbed in the Earth's surface. It's a natural process like Earth's orbits and its rotation may also affect the climate pattern. Amount of sunshine in the northern hemisphere, and the Earth has experienced a long period of colder temperature, like ice age. So there is a different ice ages happened. First ice age, second ice age. So this type of ice ages may, these are all episodes may come. In another 10 million years, we may again go into another ice age because of this will be repeated thing happen, as well as the shorter interglacial periods may also happen. And volcanic eruption, there is a notable role in climate, releases a large quantity of carbon dioxide into the atmosphere, and the particulate matter into the atmosphere can also act as a greenhouse gas or reflecting pattern. And then change in the naturally occurring carbon dioxide concentration over last several hundred years, carbon dioxide levels varied along with the glacier cycles. So during warmer interglacial periods, carbon dioxide level will be higher, but cooler glacial periods it will be lower. So that will be the problem. Whenever there is a reduce in the increase in the temperature, again melting of ice may happen, and the entrapped carbon will be getting into the atmosphere. So again increase in the carbon dioxide is happening. That's why during warmer interglacial periods, carbon dioxide levels are higher, and during the colder glacial periods, carbon dioxide level will get lower. That's the impact of global warming on melting of glaciers. Okay, so the third one is weather and climate. So rising global average temperature, because of global warming, there's increase in the temperature is a major aim. So that human-induced climate change this is. And then ocean, there is increase in the sea surface temperature and rising sea levels, increasing level of dissolved carbon. Because CO2, if it is more, then carbon will get dissolved in the ocean and changing the chemistry of carbon and more acidic. As I mentioned, carbonic acid will be formed. Snow and ice, because of melting, snow and ice pattern and the solid to liquid ratio may change. And the health and society, there may be frequent flooding we are experiencing in Chennai, and last year we have experienced in Tirunelveli, Thoothukudi. These are all not even flood prone areas. Still, we are experiencing that in the last monsoon. So you can think about every year Uttarakhand we have a flood. Everywhere we are seeing flood and this type of weather events, high wind and other direct threat to the people and property. Ecosystem will get affected, like food, clean water, and variety of, because we are not getting proper agriculture due to this climate change. Like the plants will get affected due to UV rays, and the water cycle habits and animal behavior may change. So these are all some of the events. You can see like 2021 Pacific Northeast areas of the US and Canada experienced the temperature never previously observed. That is above 40 degrees Celsius. You can see in US, if it is above 40 degrees Celsius, that is the highest temperature you can say. So that is in 2021, outside the range of the historically observed temperature. This is a very low probable event. So 1.2 degree of global warming, although aggravated by the climate change. So increase the probability of extreme heat. The impact is like 300 people got a death rate. So that is 300% increase from the average number of deaths. So you can think about that, and you can see the characteristics of the heat wave frequency, duration, season, and the intensity. Everything is getting increased, and 2010 data shows that. And cloud burst is another impact due to this climate change. You can see in the Himalayan region last year, clear evidence of climate change and massive loss of life, property, infrastructure, agricultural land, and other facilities, growing outbreak of rain. We need rain at a season, but it will not happen. But in a single day, the whole rain, that much of precipitation will happen on a single day. That's called cloud burst. So you can see the rainfall is getting increased and the snowfall is getting decreased, or the snow is getting melted. That's the impact. And the temperature will continue to rise, superimposed on natural varying temperature. And Earth's global average surface temperature in 2020 tied with 2016 as the warmest year on the record. And the frost-free season or growing season will lengthen. Frost-free season, if we length, again, there will be impact on that and increase a month or more the length of the frost-free growing season. So if the heat and trapping emissions are reduced, you can increase the considerably smaller if the heat trapping emissions are reduced. And change in the precipitation pattern, you can expect the precipitation in a single day. Heavy precipitation will even continue. Visualized in the northern part of the India, like Himalayan ranges. Sea level will get rise 1 to 8 feet by 2100. You can think about the feet, 8 feet or 1 meter. Global sea level rise to 8 inches. It is projected to rise another 1 to 8 feet by 2100. And expansion of sea water as it warms. Next several decades, storm surges and high tides could combine with sea level rise. Okay. So more drought and heat waves may happen. Heat waves, you can think about the heat waves. This is another impact of the climate change and predicted to become more intense. And once in 20-year extreme heat days, we can expect projected to occur every 2 or 3 years over most of the nations. So the two way we could respond is, one is mitigation by reducing the emission, one is adaptation by building resilient climate buildings or infrastructure. That's why civil engineers are more into this type of air pollution and climate change things. So mitigation by reducing the flow of heat trapping greenhouse gases, adaptation by reducing our vulnerability to the harmful effect of the climate change. That is, already climate change effects are there. How can we adapt to that by reducing our vulnerability? That is adaptation. Yeah. So 2018 IPCC guidelines mentioned, the report mentions 1.5 degree rise has already happened, that highlighted and it is a serious issue that was spoken worldwide. And the United Nations Framework Convention on Climate Change, that is UNFCCC, and the Paris Agreement, they have given GEF7, that's a Global Environmental Facility Climate Change Mitigation Strategy. And lots of conventions has happened, as I mentioned, Montreal, Kyoto Protocol, Paris Agreement. Everybody came and sit together to discuss about what are the ways we could possibly reduce these things. And COP, recently we had a COP again. So COP is a conference of parties, has established a forum on the impact of implementation and the response measures under the convention, Paris Agreement. And they have framed a separate sustainable development goals. So SDG, that is 13, is separately for the climate change, and they have taken urgent action to combat with the climate change and its impact. So they have different targets for that. One is 13.1, that strengthens the resilience and adaptive climate capacity. And 13.2 is the integrate climate change measures. 13.3 is to improve the education and awareness. That's what through this type of NPTEL courses they will do. That is under the 13.3 target, improve education, awareness, raising and human and institutional capacity and the climate change mitigations. Paris Agreement has happened. That is legally binding international treaty on climate change. And 196 parties at the conference COP21 in Paris that happened in 2015, and limit global warming preferably by 1.5 degrees Celsius and reach the global peaking of greenhouse gases as soon as possible. That's what the plan. And India, we have a lots of Indian National Action Plan that is called NAP on climate change, National Action Plan on Climate Change, NAPCC. So that was formed on 2008. So they have lots of missions under this, like National Solar Mission, because we need to change to renewable energy. National Mission on Enhanced Energy Efficient, and National Mission on Sustainable Habitat, National Water Mission, National Mission for sustaining the Himalayan ecosystem, National Mission for Green India, Sustainable Agriculture, Strategic Knowledge for Climate Change. This is under 13.3. And CCPI, Climate Change Performance Index, was given by globally to assess their performance on how they are performing for climate change things. So India is around 10th position, having a score of 63, and four specific categories and their benchmarks around how much greenhouse gas emission, how much renewable energy, and energy use and climate policy. These are the four parameters was assessed to give the score, CCPA score. So the final impact is acid rain. So this was we are discussing earlier onwards. So acid rain is due to the increase in the decrease in the pH of the precipitation. Or it's happening due to the fusion of say sulfur dioxide and nitrogen dioxide with the clouds, and it will form H2SO4 and HNO3 with the water. So clouds are with water vapors. H2O plus SO2 will give you H2SO4. H2O plus NO2 will give you HNO3. So nitric acid and sulfuric acids are formed that will reduce the pH of the rainwater. So that's the precipitation that contains acid components are called acidic rain, acid rain. That may be due to dry deposition or wet deposition. So like sulfur dioxide and nitrous dioxide are the major reason. Some may be due to volcanic eruptions and burning of fossil fuels. These are the two sources for SO2 and NO2 and industrial activities. Vehicles may and heavy equipments, oil manufacturers. So there are two pathways as I mentioned. One is dry deposition, one is wet deposition. Emission of SO2 and NOx will be released, transported to the long distance, deposited as wet and dry, and causes harmful effect on the soil, forest, stream and lakes. As I mentioned, 1.1 reduction in the pH may have a huge impact on the aquatic ecosystem and also to the people living there. And mid 19th century in Europe, so they has a sign of leaf deterioration. That was the first thing they have observed related to acid rain. And English scientist Robert, they have introduced the term acid rain. And 1970 onwards, there is a severity increased further. And 10 years continuous national acidic precipitation, that is NASA acid rain assessment program has happened in US, and they have studied all 5% of the England's lakes were acidic, and they have given a report. And 1990 there is a Clean Air Act 1970 decreases the total SO2 emission. Then later NOx emission was also reduced in 1990 from the automobiles by the Air Act, and Clean Air Interstate Rule reduces the pollution from the power plants. And as I mentioned, two deposition methods. One is wet deposition method, that is mostly common thing of acid rain. So acid formed fall on the ground with a mixture with rain, snow or hail. But dry deposition is absence of moisture, like deposit to the surface, water bodies, vegetation or buildings directly on that as a dry. Okay. Then measuring the acid rain. How to measure the acid rain? Normal rain has a pH of 5.6. Because why it's not 7? 7 is neutral. Because of the atmospheric carbon dioxide, there may be some carbonic acid formation. So the pH will be reduced to 5.6. That's the rainwater pH. But whenever it becomes 4.2 to 4.4, then it is called the acid rain. It can be measured with the litmus paper. As you know, strip of litmus paper change in the color will indicate you the pH level. And there is a US program NADP, that is National Atmospheric Deposition Program, and National Trends Network. They measures the deposition in 250 monitoring sites in the United Nations. And dry deposition is difficult and expensive to measure. And Clean Air Status and Trends Network, they have estimated the nitrogen and sulfur pollutants by dry deposition. And CastNet, at more than 90 locations they have measured. The impact is to the ecosystem, to the material, to the visibility, and to the human health. Ecosystem may be affected by because it's a carcinogen, it will directly affect your skin and all, and to the wildlife, fish and other species will get endangered. Some lakes in the Sweden cannot be afford to the fish life, and plants and animals cannot tolerate this acidic water, acidic sensitive, and pH declines. Young of most species are sensitive to this acidic environment, like eggs, this type of toads and all cannot tolerate the lower pH. Plants, you can see the leaf will get reduced, and there's a toxicity again. It will be acidic toxicity, change in the color, and development effects will be there. Affected trees you can see in the Smoky Mountains and the Germany Black Forest. And the buffering capacity, some soil, whenever the rainwater acidic rain falls also, it has a buffering capacity is the one that will resist the change in the pH, so that can afford to the plant growth. Still we have to study a lot about this buffering capacity of the soil to neutralize the acidity. It's also again based on the thickness and composition of the soil and type of bedrock underneath it. In northeast United States, you can see soil is thin and lack the ability to neutralize the acid in the rain. and vulnerable, and acid can accumulate into the soil and stream. Again, it will be with the rainwater, it will go and reach the water streams. So this acidity will also melt the snow and severe the rainfall events. Higher acidity results in short-term stress and ecosystem. And dry acidic particles, this dry deposition directly impact on the materials and buildings like corroded materials. You can see this is a monument affected by acid deposition. Like lots of like Taj Mahal also we have discussed in the first lecture itself. Like you can see Sphinx in the Egypt and Statue of Liberty. Everything got affected by the dry deposition of the dry deposition and wet deposition of this sulfur dioxide and nitrous dioxide. Everything related to air pollutant again. Damage to the material that cannot be repaired. Some are monuments that cannot be repaired, and increase in the maintenance cost of the buildings. So detailings can be lost, and visibility will be affected due to the deposition of this, because sulfur dioxide and nitrogen dioxide may also be transformed into sulfates and nitrates that are all particles. So particles with getting size getting increased, we will lack the visibility, and also it will form ozone. That is another secondary air pollutant that will form smog. Smog will be visibly affected. The scenic view affects, and the human health will get affected by the acid rain, and like it will create lung issue and health issues like ground level ozone, because ozone will be formed from this type of sulfate particles. So ground level ozone is a carcinogen again. So acid rain monitoring can be done with NADP, that's National Acid Deposition Program. By contained in the containers, rainwater will be collected and measured with the, and then switching is the one of the program, and scrubbing is the other program. So fuel switching is limiting the use of sulfur containing fuels that will reduce the source of emission of sulfate. So if we are not emitting sulfates and nitrates, there won't be any acid rain. So that's called switching. And switching to nuclear power generation instead of thermal power. Thermal power plants are the one which will emit a lot of SO2 and NO2. And use of solar batteries, use of energy efficient boilers, and using filters and scrubbers, that are all another way to, that is called switching and scrubbing of the oxides of sulfur and nitrogen before emitting into the atmosphere. And the conclusion is 19th century they have identified the acid rain is happening, and the source of acid rain is SO2, that is from coal combustion, and NO2, that is from vehicular emission. So that becomes a major local and regional environmental issue. Efforts to reduce the was taken globally to reduce the impact or emission of acid rain. Got it? So today we have discussed about a small part on the case study of indoor air pollution. Later 4 lecture was revolving around global impact of air pollution. That is, first one is global warming, second one is greenhouse gases, third one is climate change, fourth one is acid rain. Hope you all got it. So these are all the impacts. So next week onwards we are going to look on air pollution control measures. Okay. So if you have any doubt, please post it in the chat box, or we will move on to the problem solving session. Yeah. Hi sir, myself Sneha. I have submitted one. I haven't submitted. Will it create any problem at the time? No. So we have 12 assignments. So as per the course guidelines, the best of 8 assignments will be taken for mark consideration. So if you miss one, that is not a problem. So you can also miss 4. That is not an issue. So okay, please don't forget to give assignments on time. Every Wednesday is the deadline for the assignment submission. So this week 8 submission date got already over yesterday. Sorry, Wednesday. So we are in the 9th week now. So 9th week assignment deadline will be next week Wednesday. Okay. 9th week problem solving session will be Tuesday 68 next Tuesday. Okay. So hope I have answered your question. Please answer these questions. I will read. You can also put it in the chat box if you don't have any doubt. So in the case study related to the indoor air quality they have done in the UAE, that what we have discussed, match the pollutant and their corresponding measure equipments. So first one is TVOC, total volatile organic compounds, carbon dioxide, TSP. They have all taken 6 parameters, right? 6 temperature, humidity, CO2, TSP, that is total suspended particle, TVOC. In the indoors and like nurseries they have measured. So what are the equipment they have used? TOC was measured with the VOC environment meter. Carbon dioxide they have measured with the portable sampler. Suspended particles with the portable samplers. Carbon dioxide with the indoor air quality meter. Correct? Yes. So P3, Q1, R2 are correct. So you can see here, these are all the parameters. Formaldehyde they have measured with the formaldehyde meter. Yes. Got it? I'll move on to the second question. So in the case study related to the same indoor air quality in UAE, the most efficient way to reduce the concentration of the pollutant and improve air quality in nurseries. So they have proposed three strategies, right? One is controlling the source of the pollutant. Second one is change in the building materials. Third one is proper ventilation system and installation of air purifiers. So these are all the systems they have proposed. So which has better efficiency to improve the indoor air quality? Which has a best efficiency? Ventilation. Ventilation system they have installed as mechanical ventilation system that gives 99% of indoor air quality improvement. So you can see here. So the last point, the most effective way to reduce the concentration of pollutant was the installation of ventilation system. So they have tried with the ventilation system. They have tried with the reducing the source. They have tried also with the purifiers. So in which of the following layers of the atmosphere most of the atmospheric ozone is concentrated? So this is a basic question. So we have ozone in troposphere as well as in stratosphere, but atmospheric ozone is concentrated mostly on the stratosphere. That is a good ozone. Bad ozone is the tropospheric ozone. So stratospheric ozone is correct. So you can see here, so ozone is highly reactive gas, a combined of three oxygen atoms, and ozone is concentrated in the stratospheric layer, 15 to 30 kilometers above the Earth's surface. Got it? Yes. So the fourth question, at what time does the ozone reach its peak concentration in the diurnal cycle? So we have discussed the ozone is produced from by the ground level ozone I am not talking about. Okay. So the stratospheric ozone is formed by O2 plus O from the sunlight with the help of the sunlight as a catalyst. But tropospheric at the Earth's surface, how the ozone is formed? N2O is reacting with the N2O plus VOC gives you ozone in the presence of sunlight. So how the N2O is released into the atmosphere? Sorry, NO2 is released into the atmosphere from the vehicles. VOC is emitted from the industries. So VOC plus N2 in the presence of sunlight. I will write here if possible. So vehicles will be there that will emit NO2 or NOx. Industries will be there that will emit VOC. If this two will combine in the presence of sunlight as a catalyst, it will form ozone. This is the ground level ozone. This is a stratospheric ozone is good for the earth. Ground level ozone is a pollutant. So it's again a greenhouse gas also. So question is what? At diurnal, if you see, most of the vehicles we are using in the morning and evening. So morning it will get emitted. So this reaction will happen in the afternoon. And if you see the peak concentration, you can see at the afternoon. So noon it will form and afternoon it will be more. So you can see the answer is afternoon. See the vehicle is emitting NO and CO and RH. With the help of the sunlight, NO2 and CO and HC are formed. And finally, we could expect ozone, carbon monoxide, peroxyacetylnitrile that is a PAN, and haze. These are all the secondary pollutants formed. So afternoon you can see highest peak. Okay. So which are the following terms related to greenhouse gases describe its ability to trap an extra amount of heat in the atmosphere over time relative to 1 ton of CO2 emission? I can say to 100 years of period. What's this called? So that is a measurement technique, right? There are three measurement techniques for global warming. One is global warming potential, second one is radiative forcing, third one is annual greenhouse gas index. So these three are used as an indicator or a measurement technique used for measuring the global warming. So first one is the definition. What this definition is related to? 1 ton of CO2 can have a heat trap for a period of 100 years, which is taken as a reference. So it is called a global warming potential. So CO2 is having one global warming potential, methane is having 24, N2 is having, so this was global warming potential. You can see N2 is having 300, and fluorinated gases, F gases are having 1000 to 10,000. So that is the definition for global warming potential. So ability to trap an extra amount of heat in the atmosphere. Earlier it was natural greenhouse gas effect is there. That will be comfort effect. But whenever you are extra releasing this carbon dioxide and all, this type of methane and greenhouse gases, then it will be excess amount of heat in the atmosphere over time related to 1 ton of CO2 emission or one equivalent of. Then the sixth question. So if annual greenhouse gas index AGGI measures the climate warming impact on long-lived greenhouse gas in the atmosphere is said to be 1.0 for 1990. The AGGI of 1.45 for 2019 represent. So AGGI is another indicator, right? So we have three indicators: global warming potential, radioactive forcing, and annual greenhouse gas index. So what is AGGI? AGGI is the one which has a year-wise impact reference. So 2019 was taken as reference 1. Then 2019 is 1.45. Then what it impacts? 1 to 1.45 is 45% increase in the radioactive forcing. What it is mentioned? Radioactive forcing increase in 1990. So you can see here 1990 was taken as a reference, and if you see 2019 was 1.45, then it is representing 45% increase in the radioactive force, a net bombing influence. So we have 45% already increased the global warming in last 2 decades. Then the seventh question: the urban center that is warmer than the surrounding less populated area is called. What is that? So it's getting warmed. Less populated areas that central part is populated. If it is having a higher warm, then it is called a heat island. Surrounded by some lower population, centralized by huge population, having a huge global warming potential, that is called heat island. Which of the following is not considered as an indicator of climate change? Changing temperature and precipitation pattern, increase in the ozone temperature and sea level, melting of glaciers and sea ice, volcanic eruption. It's not considered as an indicator of climate change. Volcanic eruption is a source for climate change, but other three are indicators of climate change. So, answer is volcanic eruption. So, changing temperature and precipitation pattern is a climate change indicator. Increase in the ocean temperature and sea level increase rise is a indicator for climate change. Melting of glaciers and sea ice is again indicator. Volcanic eruption is the one which is the source for climate change. Okay. Ninth question. Which of the following pollutant are majorly responsible for the formation of acid rain? So you all know acid rain is due to SO2 and NOx. NOx from vehicular emission, SO2 is from nuclear power plants. So that's why we have a chimney height design for the nuclear power plant. We have also designed based on Gaussian plume model, and also there is a separate Q power quantity is there, right? How much quantity of SO2 we are writing, that will give you the height. So that equation, empirical equation also we are discussing in the second week. So last question. When the acidic particles and gases get deposited from the atmosphere in the absence of moisture, so SO2 and NO2 will react with the water or water vapor, give you H2SO4, HNO3. So these are all acidic acidity causing agents. So this acids will be mixing with the rainwater, and it will reduce the rainwater's pH from 5.7 to 4.4. And the nominal rainwater pH will be 5.7 to 5.9. That will be reduced to 4.4 to 4.2. Then it is called acid rain. So this deposition is happening with or without moisture. Then it is called there are two types of deposition. With moisture, then it is called wet deposition. Without moisture, it is called dry deposition. They are asking the acidic particle get deposited in the absence of moisture to the atmosphere, then it is called a dry deposition. It is in the absence of oxygen. You got it? So if you have any doubt, please let me know through mail, or you can also ask in the chat box now. I will be in the meet for next 2 minutes. So if you don't have any doubt, you can leave the meet. Thank you so much for joining this 8th week section. Don't forget to give your assignments on time. So next week we have 9th week session, problem solving session on Tuesday 6 to 8 p.m. every Tuesday. Last week I was stuck in IIT Hyderabad for PMR Symposium, so it got postponed. Sorry for that. And the recordings will be available in the Swayam portal at the problem solving session itself. So I can show you once again. So here you can see. So in the bottom, you can see the problem solving session. If you go, you can find the problem solving session recordings. You will be redirected to your Google Sheet. So there you can find on the last 8 weeks session. Okay. So thank you so much for joining. You can leave the meet now. If you have any doubt, you can unmute and you can ask, or you can post it in the chat box. And here you can see. Yeah. So in this, I have already uploaded 7 weeks. So this today's recording, I will post it today. Okay. Thank you all for joining, and all the materials you can see in this Google Drive link. Yeah. Thank you all. I'll close the meet. Thank you so much.